Hello students, welcome to Eshwari channel. Students, in this video we are going to learn about hyperconjugation. Students, hyperconjugation is also known as no bond resonance. So you know what is resonance. So resonance is nothing but displacement of pi electrons. So pi electrons will be displaced in conjugated system. So conjugated system is nothing but alternate double and single bond. Double bond, single bond, double bond. So here this pi electrons will be displaced like this. So displacement of pi electrons in conjugated system is known as resonance. So this is about resonance. So here no bond resonance. So no bond resonance is different from resonance. So this is in resonance it is pi electron displacement, whereas in no bond resonance, that is hyperconjugation, sigma electrons will be displaced. So let us take example where this hyperconjugation will take place. So first CH3 CH double bond CH2. So this is alkene. So in alkene you can see hyperconjugation. Second is CH3 CH2 positive sign, carbocation. You can see hyperconjugation in this. Third is CH3 CH2 electron. So this is carbon free radical. So in all these three you can see hyperconjugation. So what is the condition for hyperconjugation to take place? So students, there are two conditions to be satisfied. Two conditions should be satisfied, only then hyperconjugation will take place. So what is that? There should be sp3 carbon attached to double bond. So to the double bond carbon, sp3 carbon should be there, and to the carbocation, sp3 carbon should be attached, or to the free radical, sp3 carbon should be attached. So this is the first condition. So here let us check whether this condition is satisfied. So here this is the double bond. To the double bond, this is the sp3 carbon attached. So first condition is satisfied. In carbocation, this is carbocation. So to this carbon, sp3 carbon is attached. So first condition is satisfied. And free radical, to the free radical carbon, sp3 carbon is attached. So here also that first condition is satisfied. What is second condition? Second condition is alpha hydrogen atoms should be present. So what are these alpha hydrogen atoms? Alpha hydrogen atom means this sp3 carbon should be having hydrogen atoms. So those hydrogen atoms are called as alpha hydrogen atoms. So here how many alpha hydrogen atoms are there? There are 3 alpha hydrogen atom. So here there are 3 alpha hydrogen atom. Here you see 3. So 3 alpha hydrogen atoms are present. Here 3 alpha hydrogen atoms are present. So we will take one more example to find out how many alpha hydrogen atoms are there. So we will take simple example CH3, C positive sign here, and then CH3. So students, check these two conditions whether it satisfies these two conditions. So to the carbocation, so you can see there is sp3 carbon attached, and also there is sp3 carbon attached. And to this sp3 carbon you can see 3 hydrogen atoms are there. So which are called as alpha hydrogen atom. So 3 alpha hydrogen, and here also it has 3 alpha hydrogen. So totally it has 6 alpha hydrogen atoms. So both the conditions are satisfied. Therefore this shows hyperconjugation. So now we'll see in alkene hyperconjugation. CH3, I'll write it as H, H and hydrogen, and then C, H double bond CH2. So this is alkene. So in this alkene, we will see how hyperconjugation will take place. So what happens is, this is the sp3 carbon and this is alpha hydrogen atom. How many alpha hydrogen atoms are there? 1, 2 and 3. So this alpha hydrogen atom, which is connected to carbon by the sigma bond. So this sigma bond will shift here like this and this bond will shift here like this. So you can write this as hydrogen, carbon, hydrogen, double bond, CH, single bond, CH2 minus sign will be there, and this hydrogen atom will be having plus sign. So it is H plus. So second structure is, instead of this bond, if this bond shifts, so you can write it as H plus. This is H plus and this bond is shifting here. So it becomes C double bond CH, C double bond CH, CH2, and here one hydrogen will be there and here one hydrogen will be there, and here again there will be negative sign. So one more structure we can write. So I'll write below here. So instead of this hydrogen, if this sigma bond shifts, so you can write it as hydrogen, carbon, hydrogen, and here there will be H plus, and here double bond CH, CH2, and here there will be negative sign on the carbon. So these are the hyperconjugating structure. So how many structures are possible? 1, 2, 3. So there are 3 structures possible. So students, if how many structures are possible, it depends on the number of alpha hydrogen atom. Here how many alpha hydrogens are there? There are 3 alpha hydrogen atom. Therefore we can write 3 hyperconjugating structure. So we have seen how to write for alkene. We will write for carbocation now. CH, H hydrogen, and here we can write CH2 positive sign. So there is a carbocation. So now this electrons will shift here. Sigma electrons will shift. So you can write this as hydrogen, carbon, hydrogen, double bond CH2, and this hydrogen atom will be having H plus sign. H plus. So hydrogen is losing the electron, therefore it will be having plus sign. So again we can write 3 structures because 3 alpha hydrogen atoms are there. We can write 3 structures. So now instead of this hydrogen, so this hydrogen can leave with plus sign. So it will become H plus, carbon, hydrogen, hydrogen, and here there will be CH2. So this is second structure. So one more structure. So instead of this hydrogen, if this hydrogen leaves, then it will be hydrogen, carbon, hydrogen, double bond CH2, and here H plus. So this is the third structure. So this is first hyperconjugation structure, this is second one, and this is third one. So there are 3 hyperconjugating structure depending on the number of hydrogen atoms. So students, now let us see carbocations, whether we will take tertiary carbocation, secondary carbocation and primary carbocation, which is found to be more stable. We will check now. So third example, this is the carbocation. To this methyl group attached, CH3, CH3. So this is tertiary carbocation. We will take secondary carbocation. So to the carbon, two methyl groups are attached and one is hydrogen. So this is secondary carbocation. Then we will take primary. To the carbocation, only one methyl group is attached and other two are hydrogen atoms. So this is primary carbocation. So students, which is more stable now? So you know that hyperconjugation takes place in all these three, but which is stable? So to find out the stability, stability is directly proportional to the number of hydrogen, alpha hydrogen atoms. So remember this, if alpha hydrogen atom is more, then stability is more. Stability is more. This is what we have to remember. More the number of alpha hydrogen atom, more will be the stability by hyperconjugation. So we will check how many alpha hydrogen atoms are there here. So this is carbocation. This is sp3 carbon. So sp3 carbon, sp3 carbon, sp3 carbon. So 3 hydrogen atoms, 3 alpha hydrogen atom, 3 alpha hydrogen atoms. So 3 alpha hydrogen atom. Here also 3 alpha hydrogen atoms. Here also 3 alpha hydrogen atom. So totally how many are there? 3 plus 3 6, 6 plus 3 9. So totally there are 9 alpha hydrogen atoms here. In this structure you see, this is sp3 carbon, sp3 carbon. So total alpha hydrogen atom is 3 plus 3 6. So here there are 6 alpha hydrogen atoms. And in this structure you see, this is sp3 carbon and alpha hydrogen atom is 3. So there are 3 alpha hydrogen atom. So where there is more alpha hydrogen atom? 9. Therefore this is more stable compared to this, where there are only 6 alpha hydrogen atoms compared to this. So you can write here, tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation. So this is the stability order you have to remember. So students, now we will take some more examples to understand it clearly. So students, here we are going to check how many alpha hydrogen atoms are there. So here you check, this is the carbocation. To the carbocation, this is the sp3 carbon attached. sp3 carbon is having 3 alpha hydrogen atoms. So it has 3 alpha hydrogen atom. Here you check. So this is the carbocation. To the carbocation, this is the sp3 carbon. sp3 carbon, how many hydrogen atoms are there? This carbon has 3 bond. So the fourth bond will be hydrogen atom. The fourth bond will be hydrogen. So totally it has 1 alpha hydrogen atom. So it has 1 alpha hydrogen atom. Next this one. See here, 1, 2, 3. So 3 bonds are present, means fourth bond should be hydrogen. So here one more hydrogen atom will be, So this is carbocation. So carbocation, see which is the sp3 carbon. So this is sp3 carbon, this is sp3 carbon and this is sp3 carbon. So check how many hydrogen atoms are there. Here 3 will be there. This is CH3 group, CH3 group. So 3 plus 3 will be 6. So 3 hydrogen atoms here, 3 hydrogen atoms here, and here already 2 bonds are present. So there will be 2 more hydrogen atom. So 2 alpha hydrogen. 3 plus 3 6, 6 plus 2 will be 8. So totally there will be 8 alpha hydrogen atoms. So see this one. This is carbocation. The next carbon. So next carbon is sp3 carbon. Whether it has any alpha hydrogen atoms. So students, you can see there is no alpha hydrogen atom here. So no hyperconjugation takes place here. No alpha hydrogen atom. Therefore no hyperconjugation here. Hyperconjugation. So no hyperconjugation takes place here because there is no alpha hydrogen atom. So one of the condition is it should have alpha hydrogen atom. So next to this one. So here there is double bond and next to this there is sp3 carbon. So sp3 carbon is having 3 alpha hydrogen atoms. So it has 3 alpha hydrogen atom. So here this is the double bond, and here you cannot see any sp3 carbon. So here also there is no hyperconjugation, and here this is the double bond. So to this double bond, here one methyl group is there and here one methyl group is there. So there are 3 alpha hydrogen atom here, and here there are 3 alpha hydrogen atom. So totally 6 alpha hydrogen atoms are there, and here this is the double bond. So here this is sp3 carbon, this is sp3 carbon, this is sp3 carbon. So here 2 alpha hydrogen, 2 alpha hydrogen, and here there are 3 alpha hydrogen. 3, 4, 5, 6, 7. So totally 7 alpha hydrogen atoms are present. And here this is the double bond. This is sp3 carbon, sp3 carbon, sp3 carbon, sp3 carbon. So here 2 hydrogen atoms, 2 alpha hydrogen, 2 alpha hydrogen, and here 2 alpha hydrogen. So totally there are 8 alpha hydrogen atoms are present. So students, this is for you to try. So check how many alpha hydrogen atoms are there and tell in the comment section. Next we will go for this one. So there is double bond here. So to this carbon, this is sp3 carbon and this is sp3 carbon. So here methyl group 3 alpha hydrogen atoms will be there, and here 2 alpha hydrogen atoms will be present. So totally there are 5 alpha hydrogen atom. So this is how we find the number of alpha hydrogen atoms. So students, in this video we learned what is hyperconjugation and when hyperconjugation will take place, and how to find the number of alpha hydrogen atoms. In the next video, if two structures are given, how to find the stability, I'll teach you. So I'll meet you in the next video, students.